Welcome back, everyone. Today, we are looking at an absolute game changer in the artificial intelligence landscape. We're going to unpack a brilliant research paper introducing a system called HuggingGPT. Now, we hear a ton of talk about AGI, right? Artificial general intelligence. This whole idea of machines that can learn and execute literally any intellectual task a human can. But how do we actually get there? Well, Hugging GPT is a massive stepping stone toward that exact goal. And the crazy part? It does it not by building one giant, all-knowing brain, but by teaching existing AI models how to collaborate. So let's unpack this whiteboard explainer together and see exactly how they pulled this off. Okay, let's dive right into it. Here is our agenda for today. First, the multimodal AI problem. Then, Hugging GPT, the brain. Next, we'll cover the four-stage methodology, followed by real-world task execution. Then we'll look at the results and limitations, and wrap up with the path to AGI. Starting with Section 1, the multimodal AI problem. Why text alone just isn't enough. So let me start with kind of a surprising question. How exactly do we make an AI see and hear when it only speaks text? Think about standard large language models, like those foundational versions of ChatGPT. They are fundamentally text in, text out. They're incredibly smart, for sure, but they are essentially locked in a dark, silent room. No vision, no audio, absolutely no sense of the physical world. Now compare that to what real-world users actually want. We don't just want text, right? We want an AI to look at a photo and describe it to us, or listen to a video and summarize the audio, or maybe even generate a brand new image based on a spoken command. The big roadblock here is that these complex, multimodal requests are completely beyond the capabilities of a pure text model working all by itself.
Moving on to Section 2, Hugging GPT, the brain, the manager, and the specialists.
I want you to think of a large language model, like ChatGPT, as a brilliant executive manager. This manager is a master communicator, a fantastic strategic planner. But they don't know how to code, they can't paint, and they definitely can't process audio. But here's the thing. A good manager doesn't actually need to do all the grunt work themselves. They just need to know how to hire the right people for the job. Enter the Hugging Face community. Hugging Face is this massive open source hub hosting literally thousands of specialized AI models. These are our specialists. You've got one model that's an absolute expert at identifying objects in a photo, another one that only converts text to speech, another that just maps human poses. Hugging GPT is the genius system that connects our brilliant manager with this vast pool of external specialists. But you might be wondering, how do they actually talk to each other? Well, they use plain language. This is absolutely crucial. It's relying on language as a generic interface. You see, every single specialist model on Hugging Face comes with a text description. It's basically a resume detailing exactly what it does. The manager LLM reads these text resumes to understand what tools are currently available. So by incorporating these model descriptions directly into its prompt, the LLM uses language to control, schedule, and cooperate with all these external models. It reads a request, hires the right experts based on their text resumes, and then delegates the work. Simple as that. All right, Section 3, the four-stage methodology. Let's look at how the system actually works.
The researchers break this whole Hugging GPT pipeline down into 4 distinct stages. First up, task planning. The user inputs a complex request, and the LLM analyzes the intention, breaking it down into a logical sequence of subtasks. It's making the blueprint. Second is model selection. Here, the LLM basically acts as HR. It reviews those text descriptions of models on Hugging Face and selects the absolute best expert for each specific subtask. Third, we have task execution. The chosen models are actually called to action. They do their specialized jobs, whether that's processing images, generating audio, whatever is needed, and then they return their results straight back to the LLM. And finally, stage 4, response generation. The LLM gathers up all these fragmented outputs, synthesizes them, and generates a polished, comprehensive response for the user. So it's a very clean input, process, output loop.
Let's see this in action in Section 4, real-world task execution. From a boy on a scooter to a reading girl. Okay, so check out this input. The user provides an image of a boy hanging upside down on a scooter. But listen to how incredibly complex the prompt is. Quote, please generate an image where a girl is reading a book and her pose is the same as the boy in the image example.jpg. Then please describe the new image with your voice. Wow, that is a seriously demanding request. Think about it. It requires image analysis, pose detection, image generation, object detection, text generation, and audio synthesis. A standard LLM would just instantly crash and burn on this. So let's see how Hugging GPT tackles it. Hugging GPT immediately kicks into stages 1 and 2, planning and selection. The system realizes,
Okay, first I need to understand the physical posture of the boy. So it searches its list of specialists and selects an open pose model. It passes the original image straight to this specialist. And the open pose model successfully strips away all the background context and returns exactly what was asked for, a precise digital skeleton mapping out that crazy upside-down pose. And this brilliantly illustrates the modular power of HuggingGPT as we enter stage 3, task execution. The system dynamically takes the output from the first specialist, that digital skeleton, and feeds it as the direct input into a second specialist. This new specialist is a text-to-image model. HuggingGPT commands it to generate a reading girl, explicitly mapped to that exact upside-down skeletal structure. And boom, the result is a photorealistic upside-down girl reading a book. The manager has successfully coordinated its team. But wait, the user's request isn't actually finished yet. They wanted a vocal description of the new image, remember? So HuggingGPT takes this brand new image and passes it to a third specialist, a vision detection model. This model systematically scans the generated image, identifies exactly where the objects are, and detects a girl and a book. It then passes that specific data to a fourth specialist, an image captioning model, which successfully generates the text, a girl sitting on a bed reading a book. Finally, we reach stage 4, response generation. The manager model has successfully orchestrated this entire chain of specialists. It takes that text caption, passes it to a fifth specialist, a text-to-speech audio model, to generate the actual voice file. Then, HuggingGPT puts the whole visual and audio puzzle together. It presents the user with the original image, the pose mapping, the newly generated image, the text description, and the playable audio file. Just like that, it perfectly executed a hugely complex, multimodal task simply by acting as a strategic coordinator. Which brings us to Section 5, Results and Limitations. Is it actually effective? To find out, the researchers ran 130 complex human-evaluated requests through the system. And looking at the data, there is a very stark contrast between the different managers you could use. When they used smaller open-source LLMs like Alpaca or Vicuna as the controller, their limited reasoning led to pretty poor planning and some really irrational model selection. But when a highly powerful LLM like GPT 3.5 was deployed, success rates absolutely skyrocketed. Why? Because a powerful manager has the vast contextual understanding needed to handle a massive memory window of the specialist resumes, allowing it to synthesize inputs logically. So, in plain English, the success of this entire system is completely dependent on having a highly intelligent manager at the center. A model with limited reasoning makes bad plans and hires the wrong specialists, while a powerful manager coordinates the whole shebang flawlessly. Which, of course, brings us to the limitations, and the authors present these fairly and rigorously. First, as we just saw, the system is entirely bottlenecked by the intelligence of that core LLM. If the manager isn't smart, the system fails. Second is efficiency. Bouncing data back and forth between a central brain and multiple external models takes time and serious computing power, so it definitely isn't instantaneous. Third, we have token length limits. The LLM has to read the text resumes of all the available models. If there are thousands of models, the prompt eventually just becomes way too large for the LLM's memory window. And fourth, instability. Sometimes the LLM hallucinates a model that doesn't even exist, or it fails to format the handoff properly, which completely breaks the workflow. So it's a massive breakthrough for sure, but it's important to remember that this is still a very evolving science. Finally, Section 6, the path to AGI, why this paper really matters. The authors conclude their paper with this really powerful statement. They write, by utilizing the ability of numerous AI models, HuggingGPT demonstrates immense potential in solving challenging AI tasks, thereby paving a new pathway towards achieving artificial general intelligence. The takeaway here is profound. The path to AGI might not actually about building one monolithic godlike model that inherently knows everything. Instead, it might look a lot like this, an ecosystem of open source collaboration where language models act as central nervous systems, naturally orchestrating thousands of highly specialized tools. It completely reframes how we think about the future of problem solving. We are rapidly moving away from isolated chatbots and toward collaborative autonomous agents that can literally reach out and utilize the brainpower of the entire machine learning community. So I'll leave you with this thought. Knowing that an AI can now dynamically plan, hire experts, and synthesize results across audio, video, and text, what complex AI task would you ask HuggingGPT to solve today? Thanks so much for exploring this with me on this explainer, and I will see you next time.